Welcome once again. We were discussing about Linux biography in the previous video. Now comes down to hardware requirements for Unix. Right now I'm on a 32-bit processor laptop with the Linux Mint and across 2 GB of RAM. Yeah, it is 2 GB I guess. So never mind, hardware requirements for Unix are really very cheap. You just need 80 MB hard disk and a 4 MB of RAM. Okay, so that's quite small, and a 16-bit of microprocessor. However, one more question is that we all know that Unix is a multi-user operating system in which we have a host machine and there are different terminals connected to the host machine. So how do we connect the terminals to the host machine? The answer is very simple, through a 4, 8 or 16 port controller card installed in the expansion slot on the motherboard of the host machine. One end of the cable is plugged to the port on the controller card and another end to the serial port that may be 9-pin or 25-pin of the terminal. So overall, we can say that any DOS-based machine with a serial port can act as a terminal. One more thing to be noted is that not only out of 80 MB, almost 40 MB eaten by the actual Linux OS files, whereas another 10 to 20 MB is used as a swap space. The swap space is used when Unix falls short of memory. At such times, it temporarily stores in this swap space the contents of the memory which are not immediately required. Whenever these contents are required, they are read back from the swap space. Another thing to be noted is that more the number of terminals, more should be the memory on host machine, of course. As a thumb rule, we can say that per terminal to be supported, 0.75 to 1 MB should be present in the host machine. So that's all for the hardware requirements. Next comes down to salient features of Linux. They are multi-user, multitasking, communication, security, and portability. We'll come down to multi-user capability. In a multi-user system, the same computer resources, that is hard disk or memory, etc., are accessible to many users. Of course, the users don't talk together at the same computer, but are given different terminals to operate from. A terminal, in turn, is a keyboard and a monitor, which are the input and output devices for that user. All terminals are connected to the main computer, whose resources are availed by all users. So, a user at any of the terminal can use not only the computer, but also any peripherals that may be attached, say for instance a printer. One can print from another computer connected with the another computer of the printer. So these can be exchanged easily. All the resources, all the memory, all the peripheral devices such as printers, input-output devices. The number of terminals that can be connected to the host machine depends on the number of ports that are present in its controller card. For example, a 4-port controller card in the host machine can support 4 terminals. There are several types of terminals that can be attached to the host. These are dumb terminals, terminal emulation, and dial-in terminals. Dumb terminals are those terminals. These terminals mainly consist of a computer and a display unit with no memory or disk of its own. These can never act as an independent machine. If they are to be used, they have to be connected to the host machine. While the terminal emulation, in this, a PC has its own microprocessor, memory, and disk drives. By attaching this PC to the host through a cable and running a software from this PC, we can emulate it to work as if it is a dumb terminal. At such times, however, the memory and the disk are not in use, and the PC cannot carry out any processing on its own. Like a dumb terminal, it transmits its processing job to the host machine. The software that makes the PC work like a dumb terminal is called terminal emulation software. Some of the examples of these softwares are vTerm, or you can say Xtalk, Xtalk, or vTerm, VTERM. Another one is dial-in terminals. These terminals use telephone lines to connect with the host machine. To communicate over telephone lines, it is necessary to attach a unit called modem to the terminal as well as to the host. The modem is required to transmit data over telephone lines. Next comes down to multitasking capabilities. Multitasking implies that it is capable of carrying out more than one job at the same time. We all know that. This is managed by dividing the CPU time intelligently, intelligently between all processes being carried out. This is managed by dividing the CPU time intelligently between all processes being carried out. Depending on the priority of the task, the operating system allocates small time slots to each foreground or background task. The very concept of a multi-user operating system expects the same to be multitasking too. How? We can say this because even when a user is executing only one command at a time, the CPU is not dedicated to that user. In all probability, there are 10 more users who also demand execution of their commands. UNIX therefore has to be on its toes all the time, obliging all the users to be connected to it. MS-DOS also provides a multitasking capability. The type of multitasking provided by MS-DOS is known as serial multitasking. So in this way we come down to Linux versus MS-DOS. In this MS-DOS, the type of multitasking provided by MS-DOS is known as serial multitasking. In this type of multitasking, one program is stopped temporarily while another is allowed to execute. At any given time, only one task is run. You can liken this to a situation in which a human working on a computer stops his work to answer a ringing phone and then, having finished with the call, switches back to the computer. While UNIX uses parallel multitasking, it doesn't give equal time slices, and those that wait for user responses are given a high priority. The multitasking of UNIX is really different from DOS, which does not give time slices to running programs. And if there are 5 programs running in DOS and even one goes haywire, hang, the entire machine hangs. In any genuine multitasking environment like UNIX, this doesn't happen. There may be some programs that are relatively more important. For example, those that wait for user responses are given a higher priority in UNIX multitasking operating system. Programs which have the same priority are scheduled on a round-robin basis, that is one by one. Next comes down to communication. The communication may be within the network of a single main computer or between 2 or more such computer networks. The user can easily exchange mail, data, programs through such networks. Distance possesses no barrier to passing information or messages to and fro. You may be 2 feet away or at 2,000 miles away, with hardly take any time to reach its destination. Communication. Another comes down to security. UNIX has 3 inherent provisions for protecting data. The first is provided by assigning passwords and login names to individual users, ensuring that not anybody can come and have access to your work. At the file level, there are read, write, and execute permissions to each file, which decide who can access a particular file, who can modify it, and who can execute it. You may reserve read and write permissions for yourself and leave others on the network free to execute it or any such combination. Lastly, there is file encryption. This utility encodes your file into an unreadable format so that even if someone succeeds in opening it, your secrets are safe. Of course, should you want to see the contents, you can always decrypt the file or decode the file. That's all for the introduction part. If you like this video, please give a thumbs up, and the whole PPT I will provide you in the description box. If you want it, you can get it from there. And if you like this video, please give a thumbs up, please rate, comment and subscribe, and wait for the next video. Bye bye.